So I'm Chris. Can you guys hear me? Cool. This is React, evented programming in PHP. And this is an interactive presentation. So at the bottom, if you manage to get on Wi-Fi and want to go to that URL, you can follow along in the slides. I recommend Chrome because I fail at CSS, and it doesn't work well in Firefox or Safari, and I haven't even tried IE. Okay. So most PHP development is meant for websites. That's what PHP is originally created for. And when you go to a website and go to hello.php, what happens is it looks on the file system, usually does one-to-one mapping, finds hello.php, executes it, and returns it to your browser to render. And evolution, PHP has evolved a little. A lot of people use mod rewrite with Apache to route everything to the index, and then PHP will include its own files. But you're a slave. CGI has been the world that's been pulled over your eyes to blind you from the truth. And that is, when you go to the URL, you are not actually accessing a file system. You are accessing running applications. Now, how does this work? Your browser is an HTTP client. It will open a connection to an IP address and make a request to the server with using the HTTP protocol. The server will handle it, execute some scripts, parse it, and send it back. And then the connection is closed immediately. It is stateless. From connection to connection, there's no statefulness. We use sessions and cookies passed on each request to fake a stateful presence. What's in a message? So the web is run over TCP, Transmission Control Protocol, which ensures delivery. It's very reliant. If packets fail to get delivered, it will send them again. A TCP packet walks into a bar and says, "I want a beer." The barman says, "You want a beer?" And the packet says, "Yes, a beer." And that's how TCP works. After the TCP connection has been established, the client will send an HTTP request. And this involves a method, an endpoint, and a version, followed by HTTP headers, and finally the HTTP body. Then inside the body, actually with the headers and the body together, there's a format. So your content is the final payload, but that will be wrapped in JSON or HTML or CSV or some kind of format. And this pattern works for request and response. You request it in this manner, and it is sent back to you in the same manner. Here's a diagram of a sample server. So when you make a request, it will go through the internet, possibly, hit your running server, which could be light HTTP, Apache, or Nginx. This diagram is using Nginx. So how that works is Nginx actually uses the Reactor pattern. It will handle your request, decide what to do with the content in the HTTP header, and then hand off to the next process. So if you request something like a JavaScript file, CSS file, an image, or that kind of thing, typically it will go to the file system, fetch that file, and return it to the client. If you request a PHP, Nginx usually will talk to PHP FPM, which is has several running processes which load your PHP script in memory and will execute it with your variables from the HTTP request. And this is using FastCGI. To parse the HTTP into PHP variables. Anyone see the error in this? Good. Okay, so how does a socket work? A socket is a lot like a telephone. The client will open a connection to a server. The server will decide whether or not to accept the connection. And then the client, once the connection's been established, a client and server can send messages back and forth to each other. And this is the core of TCP, which has been around for 50 years. And it is stateful until one of the client or the server decide to hang up. The connection is maintained. So opening up your eyes a little, I'm going to strip away a layer and use curl. Who here has used curl before? Excellent. So if you're following along, you can actually copy and paste that URL into a terminal and see the result for yourself. And that will actually contact my server here and give you a response. So curl is just taking away what the browser does, and that is rendering HTML, CSS, and JavaScript. You just get the raw text of your first response. And you can see the response coming back. So if we take away one more layer, curl is smart. Curl knows the HTTP protocol and how to handle certain things like cookies, SSL, and many other things. Curl is very good. So we want to take away one more layer here. And using telnet. Who's used telnet before? Awesome. So if you type this into your terminal, telnet, connect to my IP address, and the third parameter is port 80, which is what most websites run on by default that aren't SSL. And then you type get/HTTP11 return host my IP address, and then hit return twice. So if you do that, you will get the raw HTML back from my server. And you are typing out an HTTP request by hand. As of PHP 5.4, it comes with a built-in web server, so something that other than Apache or Nginx. So if you type PHP -S 000, which is meaning binding to your machine, but allows other machines to access it, and then :8000, so bind to port 8000, and alice.php is a script. And if you curl -v my machine on that again, actually I don't think I have that running, don't do that. You will get back the response. And this is PHP itself handling the HTTP request. So if we go back to slide 6, we are now, this has taken away Nginx, PHP FPM, and PHP is kind of put in front of that now and is handling the requests and the responses. So we're taking away layers. But respect the double claw. This is not good. The PHP built-in server is not meant for production. The problem is, it is blocking. It handles one request at a time. PHP actually recommends not using this in production. I'm not just being mean. It is an excellent, excellent tool for testing locally. If you don't want to go through the hassle of setting up an Apache or an Nginx or what have you server, you can just use this server and it is good. Now, what does blocking mean? Blocking means it is synchronous. It handles one request at a time. So if you go to if you make a request to a website, you will actually not be making one request, you'll be making many, usually. Once you get back that first response of HTML, it has CSS, JavaScript, and all this embedded links in it, and you make return trips to the server to access that. Now with the PHP server being synchronous and blocking, it will handle it one at a time, and it's a queue. It will only finish responding. It will only take the next one after it's finished the one process. And this is like standing in line at the DMV. You have to wait. They have one person open, and you have to wait for that person in front of you. And this is also like a single lane traffic on highway with a slow truck leading the way. Blocking and synchronous is not bad. MySQL client in PHP is blocking, and this is a good thing. After you make the request, so select a row from a table, you're actually communicating to MySQL through sockets. It's just been abstracted away for you, and all you use is the API. So once R has been made, or once line 3 has been executed, it waits for MySQL to respond before executing line D. And you can see if we just went through that and didn't wait for it to return, there'd be huge problems. You wouldn't have data, would probably have some kind of errors. And this just shows MySQL itself would be asynchronous. A synchronous process can talk to an asynchronous process. Now an event loop. I mentioned Nginx earlier. It runs on an event loop as opposed to Apache, which runs in a threaded model. The way an event loop works is while true. Everything you do just gets repeated. And inside that, it'll be waiting for I/O. So while you wait for events, that waits for something to come in, that waits for a connection, a socket connection. And then once something's happened, an event is triggered, and it flows through the rest of your code. You would have a handler or a callback. And the more you put on your handlers and callbacks, the bigger the loop will get, and the more time it'll take to execute, and the slower your process will be. Unix philosophy. The rule of composition states, developers should write programs that can communicate easily with other programs. This rule aims to allow developers to break down projects into small, simple programs rather than overly complex monolithic programs. Smaller units are less prone to error. When you write several small things and piece them together, each small thing, if it only does one thing, is much less prone to error, and it's much easier to test. So if we go back to slide 6 again, this is showing a small part of the Unix philosophy. And if you have a bigger, large-scale application, you have caching and maybe varnish and some other a load balancer in here. But Nginx does one thing. It redirects traffic based on a request. PHP FPM does one thing. It spins up PHP instances and executes your code. In practice, this is much like an assembly line, as opposed to the DMV line. Each process does one thing, and does it very well, and it makes the system as a whole faster. Each process is only waiting for its one task to income and then output. So what is the Reactor pattern? The Reactor design pattern handles service requests that are delivered concurrently to the applications by one or more clients. Each service as an application may consist of several methods and is represented by a separate event handler that is responsible for dispatching service requests. So what does this mean? How does that work? It's a lot like a telephone operator in, I don't know, the 50s? Earlier than that? So a person will call in and the operator will take the call and reroute it to someone inside the building. And that's kind of a way you can think of the Reactor pattern. There can be a lot of incoming requests, and when you bind it to an outgoing, someone else in the office, you can bind it to not just one, but other people, more than one person. So now let's get to React, the PHP library. And apparently that's for developers too lazy to learn JavaScript or Node.js. But if JavaScript looks like a cat with a horse head, it must be JavaScript. JavaScript sounds kind of hard, doesn't it? So React is asynchronous, non-blocking I/O. It is event-driven, so when something happens, you can trigger another action. And it is PSR 0, 1, and 2 compliant on packages, GitHub, and it is very unit tested. And it's fun to program with. Has everyone here used Composer or packages before? Okay. So the first thing a lot of people tell me about this is PHP was never meant for long-running processes. It can't handle it. Nikita Popov is a core contributor to PHP. And he says, if you have memory leaks in your application, odds are it's your fault. PHP is very good at garbage collection, and it can do long-running scripts, especially since 5.3. I've had several scripts running for months without crashing. It's not a problem. So first thing to install React is in your composer require file, require React socket 0.3 to write a socket server. So let's just take a look at this code for a moment. And this is a socket server written in React. So what this does is you will create an event loop with one of the APIs. You will create a socket server and inject the event loop into it. And on an event, a connection, we are going to echo out that there was a connection made. And when we receive data from that connection, we are going to echo out that we received data, and as well write back to that connection what they said to us. And at the end, we are going to say listen on port 1337 and bind it globally. And then we're going to run our event loop. So once we do this, it starts the event loop, and the script will not exit until it crashes or you kill it. So a working demo right here. If you open up Telnet and connect to my machine, you'll be able to do the same. Anything you type will be immediately sent back to yourself. Not that useful, but introduction. Okay, so next step is, I'm sorry, yes? Oh, I thought you had a question. My apologies. So the next step is, oh, one second, I want to go back for a moment. Something I didn't make clear is, traditionally when you work, and with Apache and Nginx and FPM, each PHP connection is siloed into its own runtime instance. You cannot communicate with another connection when you are handling that. Everything you write is isolated to the one user who made the request. This is very different in React and this event-driven programming. You have one script and one set of globals. The globals are not isolated to one user, they're isolated to the context of your script. Each user connecting is represented by an object in there called con, which has its own methods, and that is how you interact with the user with that connection. So next demo is kind of similar. We'll create an event loop, create a socket server. We're using SPL object storage. Who's familiar with any of the SPL object or data stores? They're very neat. This being a long-running process, I suggest it's very useful to look into them. They function differently than arrays, but they are just containers, like arrays. But arrays are very all-purpose and very bloated and can consume a lot of resources. And resources are something you need to worry about when you're making long-running scripts with many, many users connecting to one single script. So this one, kind of similar, make a connection. We're going to attach it to the SPL object, which is like adding it to an array, but the SPL object only handles objects. When a connection is made, or when we receive data from a connection, we will then loop through each connection that is not ourselves and write to that connection the data received. So, and then when the connection ends, remove it from our lookup of other connections and bind it to 9000 and loop run. So if anyone wants to connect in Telnet to my server, I don't have the IP address anymore, and Telnet's in 9000. So you guys are now talking to me, and I'm sending messages back to you. So now I'm going to show the real power of a reactor pattern. So given the same script, if we had a new chunk of code, we're making another socket server and injecting it to the same event loop. So this event loop, which handles all events, now has two servers bound to it. One is port 9000, our previous one, and now we have 9001. But in my script, which I haven't shown you, I've only tied it to my local IP address, so only I can connect to it. And what this does is it will broadcast messages to everyone else on port 9000. Very nice. Did everyone get that? Who is connected? Anyone? Sure, sorry about that. Yep, there you go. So as you see here, on my connection to 9000, which everyone who's following along would be on, I received the broadcast message. But when I send a message from port 9000, port 9001 did not receive it. So this is a kind of pseudo-hierarchical architecture. But we're just sending raw data. Not very useful. And this is not how the connections work. What matters are protocols. And a protocol is a standard procedure for regulating data transmission between computers. This is how other systems communicate with each other, is through protocols. And we saw at the beginning of the talk, HTTP is an example of a protocol. It's text-based and it's very human-readable. So some examples of some protocols are JSON. It's human-readable, computer-parsable, and used as a data transport for most data on the internet. It's become a very popular protocol because it's so easy for humans to read and write. Another protocol, DNS, is a binary protocol. So when you connect to a host name, that makes a request to a DNS server and uses this binary protocol to retrieve back an IP address. Because that's how TCP/IP works, is you need to connect to an IP address. Another example is Speedy. Speedy is a web protocol made by Google because they found HTTP to be too slow and too resourceful. And this Speedy now has evolved into HTTP2, which is, instead of traditional HTTP1 being a text protocol, will be a binary protocol. Another protocol, Redis, human readable. So a few React libraries. I demonstrated socket server and event loop. And event loop is the core of React. It is what React was named after, the Reactor pattern. And we have several other libraries that bind to the event loop and are asynchronous. So Stream, which is a wrapper for Stream PHP wrappers, and will also be used once we have asynchronous file I/O. Promise, which is the answer to nested callbacks. I'll cover that more later. We have asynchronous DNS. 0MQ, which I will get to a little bit later. I could do a whole talk on that, but the way I like to describe it is TCP on steroids. Stomp, which is a text-based protocol, supported in React. I believe Igor wrote that, and the main purpose of that was to talk to RabbitMQ. We have an HTTP server, which should not be used in production, but we wanted to write one. It was fun. Some uses for that are if you don't have 5.4, that could be a good server. Sculpin, a blogging tool, uses it for testing. We have an HTTP client, which will make asynchronous HTTP requests. And finally, a socket client, which will make asynchronous socket requests without a protocol. So the loop interface, this is the interface to loop. We have add stream, remove streams, and add timers and periodic timers. Each time a loop goes through, it's called a tick. So run will just enter the event loop and wait for events to happen. And you can bind, before that you can bind or remove, actually while it's running even, streams to this. And these are PHP streams. Has anyone ever used PHP stream wrappers? A few people? Okay. So our loop interface, we have several implementations. We have stream select loop, which works on all systems. Lib event loop, which currently I think is our best option. Lib event loop was created to handle the C10K problem, which is handling 10,000 concurrent connections. libev, which was modeled after libevent, but as the author writes, without libevent's limitation or bugs. I think that's a little biased, but I don't know enough to really comment on that. libuv, we have a PR in testing. libuv is what Node runs on and how Node is so fast. And finally, event loop, which is just another implementation of libevent. Now, how all these implementations work is there's underlying C extensions for PHP, and so as well to create bindings for us to use. The event loops are tied to the kernel of the operating system and use various methods. Stream select loop was the original event loop, and it can only handle 1,024 connections, so it is not ideally meant for a server. And the rest of them will use the kernel events that are available. Linux has epoll, which is relatively new, and that was created to just handle more connections. KQ on BSD, and I don't remember the Windows one. But these all interact with the kernel in that way and provide bindings to PHP for you to access them. And then we've wrapped that in our stream, our event interface. So has anyone written in any language code that says, do this, and then when that's done, have a callback, do this, do this, do this? Anyone done, yeah, callback hell? So one way of tackling that problem is using promises. And has anyone used Node.js? Does anyone ever follow the forums? If you say a word about promises in Node.js, you are going to get crucified. They were in 0.2 and then they were taken out. And if you talk about putting them into the core, you're just flame bait. So a promise is like a one-time stream. A promise is an object that you are given, and it has two methods, or two callbacks, fulfilled or rejected. So that's like a success or an error callback, but you're binding it to an object. At some point in time, this promise will be fulfilled. You don't know when. It just will happen eventually. The server can choose to respond at any time, and the promise can be reused. And this is a very neat part of the promises. So here's an example of using a promise, which we have chose to use in the asynchronous DNS client. So we create an event loop factory, a DNS factory, and bind it to 888, which is one of the primary DNS servers. So if that is your DNS server on your computer, when you type google.com, it goes finds their IP address, and then you make a connection to that IP address. So the API is you ask you want to resolve reactphp.org, and then you were given a promise object, which is returned to you. And the promise object has a then. So when the promise has been completed, either fulfilled or rejected, we have a callback, and value is the IP address. The second parameter would be a failure. So one of the large benefits of this is reuse. Excuse me. So same code here. We get the promise. We store the promise in a variable this time instead of chaining. And when it is resolved, we echo the IP address. This isn't a practical example, just meant to show you how it's meant to be used. And again, later, or immediately, we say DNS promise, and then we do something else with the same value. Now what this does is it does not make two requests to the DNS server for your IP address. Once it has been fulfilled, the object is stored and maintained, but the API remains the same. So you can pass this object around and reuse it without requesting the server again. And you don't have this callback chain. And you don't have any temporary variables. You don't need to take that IP address, store it somewhere. You just have the one object with the one API. And you have a better state management. So how do you create a promise? A promise is created with a deferred object. Deferred object has two properties or methods attached to it, which is the promise, which is the external API. If you are writing something that is to be fulfilled, if you are a producer, not a consumer of this, you will create a deferred object and hand the promise back to the consumer. And then, whenever you're ready, like after a certain period of time, after a request was fulfilled, something asynchronous probably, you will use the resolver, and you can resolve or reject the promise. And then the callbacks for anything that has tied itself to the promise will be executed in order. So here's a fantastic, convoluted, terrible example of using of creating your own deferred object. So we have a closure that takes a loop. We create a deferred object inside that. We add a timer to the loop to say, in 1 second, execute this code. We generate a random number, and if it's even, we say the promise is resolved, it's good. If it's odd, that's not good. We reject the promise. And then we return the promise. So the consumer at the bottom will create a new random promise and bind two functions, two closures to that. That when the promise is resolved, we get the number, we echo what it is, and if it was rejected, we do the same thing. A very useful and practical example is when you have multiple number of promises. And this is, I think, what the real strength of promises is when you have a lot of asynchronous requests as a client. So if you were to make an HTTP request to an external API to get their user info, and you want to check that against your database, and assume that these two fake methods I created are an asynchronous MySQL and HTTP client, you would say promise all means when all promises have resolved, execute it. So promise all takes an array of promises, and when all those promises are fulfilled, that's when we do something, and we get an array of results back in the order that we asked for the promise. Now, this is very good because the HTTP request and the MySQL request can both be executed at the same time. Remember earlier from when the database, where I said, oh, wouldn't this be bad if that blocked and just ran through? Well, this is running through because we expect it to. So we put out a request to an HTTP server, and that takes time. And immediately we put out a request to the MySQL server, which takes time, and probably less time. And we don't know which one's going to finish first. And we don't want to manage state either. This could be 3 or 4 requests. And we're going to handle them all at the same time. We let the promise API of all say, when you're all done, then we do something. And this is a much cleaner API than trying to manage all the state yourself. So streams. Streams are an API for handling input and output. This demo's been all about networking and sockets and TCP. But streams are a generic wrapper for anything that can be asynchronous. The next most common thing would be files systems, which we don't have in React, which we have in a PR and are trying to work on. And this API just makes manipulating connections easier. The readable has a few methods. If the stream is readable yet, you can pause the stream to not receive any more data. Resumes it if it was paused. And you can pipe to a writable stream. So that would say all incoming data, redirect to an output. And writable has, if the Boolean is writable, write data, which we saw in the example earlier, writing to telnet, telnet clients, end, which closes the connection after sending a certain amount of data. And streams do a lot of nice things as well. They buffer. Part of the way it handles, the API makes TCP easier to work with. Features coming soon in React when we get around to merging 0.4. Child process, made by Jeremy up here, thank you. This will let a script execute another script from within itself and handle its input and output. You can talk to this child process that you control. And what makes this nice is that the child process can do blocking things like MySQL. Unfortunately, a lot of protocols in PHP, all the protocols in PHP are synchronous, and we've written some to be asynchronous, but not all. MySQL, Postgres, PDO, a large number are. So what this feature would let us do is have a separate script that does make blocking calls, and the parent script that executed it could talk to it and say, do this query for me, and tell me when it's done. So the parent can run asynchronously while the child runs synchronously. And that's just one example of how to use it. Next tick, made by Jay Malik. A tick is when the event loop comes around and there's something to happen. Next tick means, in the order that the event loop processes events, say there are several to take at one time. 2 users connected, and that has to be handled. One connected user sent a message, and that has to be handled. It still handles them one at a time, but when it goes to TCP, that's when it's handled asynchronously. The processing order of the event loop, if I remember correctly, is it will handle TCP first, timeout second. So when you say put something on a loop, execute in this amount of time, or execute on this interval, that will be handled next. And then finally, next tick will be handled. So, where's that first? There's 2 APIs, my apologies. One adds it to the beginning and interrupts, says, no, do execute this before anything else on the event loop. And one says, okay, add to the end of, okay, when you have nothing left to do, event loop, execute this code. Both of those are coming. New A+ promise API. Thanks to Jansor. The examples I gave were using the new Promise API, which is being rewritten for version 2. And it uses the A+, which is a specification for how promises should work. And any language that is implementing promises is implementing it using this protocol. What we plan to be doing, this has already been done, but we're planning to move our client libraries to be using this API. Socket client currently does callbacks, and we plan to replace that with promises, as well as the HTTP client. This entire presentation has been talking about TCP, and JSOR, another clue, has implemented UDP, and we're looking to merge that in. Refactoring the event loop interface, that's probably going to come in 0.5. The event loop interface I showed, we're probably going to change because this is currently still is beta. And an easier framework. We've talked about, this is very object-oriented and very good structure for writing code, but it can be monotonous. So we're thinking of writing a new library that just kind of makes it easier to use and have a more opinionated API. Please rate my talk on Joined In. Feedback, very welcome. If you don't let me know what I'm doing wrong, I can't correct it. Find me at Boden C on Twitter, reactphp.org, and this presentation is available on GitHub.